Hi guys, and welcome to your first Calgebra video of the year. This video is going to look at some word problems that would be covered in Chapter 1. There's going to be 6 different things we're going to talk about. First will be just telling a story through algebraic symbols. Next will be consecutive integers type problems, problems about distance, rate, and time, investment problems, mixture problems, and coin problems. And so we're going to do one example of each of these. The focus here will be on the setup and then checking our solution. You always want to double check that your answer makes sense. First of all, that you're answering the question that's being asked, and also is your answer reasonable? Considering sometimes negative numbers or non-whole numbers wouldn't make any sense. There'll be times where you need your numbers to be either odd or even. Depends on the problem. So always just double check by going back to the question, and I won't be going through step by step all of the work to solve each equation. I will show you that, but I won't be discussing it because you all know how to solve equations, and none of them require any special strategies. All right, so let's take a look at some of these problems. All right, this problem comes from your textbook, page 48, number 21. Max has twice as much money as Katie, who has $12 more than Greg. All three together have $124. How much money does each have? So this is just telling a story. We're looking at this here, and we want to translate this tale into algebraic symbols. So a couple of ways we can do this. First of all, we maybe want to identify who we have here. We have Max, and we have Katie, and we have Greg. Now, we kind of want to see who this is based off of. Well, Max is twice Katie, and Katie's 12 more than Greg, so we can actually tell the whole thing based on Greg's amount of money. So I'm going to actually call that G. Greg has G dollars. Now, Katie has $12 more than Greg. So if it's 12 more than Greg, that's going to be G plus 12. That's $12 more than Greg has. And Max has twice as much as Katie, so that's going to be 2 times whatever Katie had, which was G plus 12. And so now we just tell the story together. We know that Greg and Katie and Max together have $124. And that's our setup. We're just telling the story, retelling the story using algebraic symbols. So now I'm going to go ahead and solve this, and you can check out the solution. You can try to solve it now, pause the video and solve it yourself, and then double check your work, or just go ahead. So here we are. And this shows us that Greg has $22. Katie, who has 12 more than that, therefore must have $34. And Max, which has who has twice as much as Katie, must have $68. So we properly label them, and just do a quick check to make sure they have $124 altogether, and they do. And so our answer makes sense, and we're good to go. And that's all you need for this telling a story problem. All right, our next problem comes from page 47, number 17. It says a quadrilateral has a perimeter of 60 centimeters, and the lengths of its sides in centimeters are consecutive odd numbers. Find the lengths of each side. So I'm going to start by just drawing a diagram of a quadrilateral. Quadrilateral is a 4-sided figure. It doesn't need to be anything special. It might not be a square or a rectangle. You could draw it that way, but just 4 sides. And I've got 4 side lengths, and I know that perimeter is telling me I'm talking about the distance all the way around the figure. But I don't know entirely what they are, but I do know that the lengths are consecutive odd numbers. And when they're consecutive odd numbers, that means I have a starting point, which is unknown, and I can call that x. Now the next odd number would be 2 above that. For example, 3, 5, 7, 9. To get from one to the next, you go up by 2. So my next side would be x plus 2. I'd continue that and get x plus 4 by adding 2 to the x plus 2, and then adding another 2 gives me x plus 6. This actually would be the exact same setup if I was told they were consecutive even numbers, because to go up to the next even number, you again go up by 2's. If they were just consecutive integers, then I would have x plus 1, x plus 2, x plus 3, because you just go up by 1 to go up by each integer. All right, so now that I have that, I use the idea of perimeter to create an equation. And I know that I'm going to have x plus 2 plus x plus 4 plus x plus 6. And that's my perimeter, so that's going to equal 60 centimeters. Perimeter just means adding up all 4 sides. So either pause the video and try to solve it yourself, or just go ahead and see what the solution is. So we can see that this gives us a value of x equals 12, which I just go back up into my diagram, means that this side would be 12 centimeters, the next side would be 14 centimeters, keep on going around, 16 centimeters, and 18 centimeters. And a quick check will show us that these 4 side lengths will all add up to 60 centimeters, and so those would be the lengths of each side. However, I mentioned before, we always want to make sure that we have an answer that makes sense. And what we were told originally is that we're dealing with odd numbers. Here, my answers are all even. And because I can double check my math and find that there was nothing I did wrong, it turns out that this is a special type of problem that has no solution. There is actually no set of 4 consecutive odd numbers that will add up to 60. Only even numbers, 12, 14, 16, and 18. So this problem actually has no solution, which is an acceptable answer some of the time. All right, hope that this was clear. Let's take a look at another one. All right, next problem comes from page 53, number 19. At noon, a train leaves Bridgeton, heading east at 90 miles per hour to Cogsville, 450 miles away. And at 12:15 p.m., a train leaves Cogsville, heading west to Bridgeton, at 100 miles per hour. At what time will they pass each other? So this is a distance, rate, and time problem. It all comes back to a formula you're probably very familiar with, which is distance equals rate times time. Now that formula can be manipulated, moved around a little bit. It's equivalent to time is distance over rate, or rate is distance over time, but generally speaking, I call these DIRT problems, DRT, distance equals rate times time. One way that's really easy to do this is to set it up in a table to help keep that organized. So we're going to have the train from Bridgeton to Cogsville and from Cogsville to Bridgeton. So I'm going to set up that table. So I'm just going to take the information that's given to me. First, I have the train that leaves Bridgeton at 90 miles per hour to Cogsville. So from Bridgeton to Cogsville, I know its rate is 90 miles per hour. So I'm going to fill that in there. I'm not going to worry about putting the units in, but that's okay. And I don't know the actual distance that it travels. It's not getting all the way there. But I do know that that's going to be related to the time that it's driving. And since that's what I'm actually interested in, I want to know at what time will they pass each other. The time is going to be my big variable. So I'm going to use that as x. X is going to be the amount of time that we're on the road there. And now, using the formula that I discussed earlier, d equals r times t, I can create an expression for this distance by multiplying the rate times the time and get 90x. So the train from Bridgeton to Cogsville is traveling 90x miles in x hours. Now I have the second train, which goes from Cogsville to Bridgeton. And that's going at 100 miles per hour, so 100 is its rate. And how long is that train traveling for? Well, since they're ultimately passing each other, they're going to be passing each other at the same time. But the train from Bridgeton left 15 minutes earlier. So the second train has 15 less minutes of travel time than the other one. Say at 1 p.m., the first train has been going for an hour, the second train has only been going for 45 minutes. Now, since x was measured in hours, I'm going to do the same thing with my time for the Cogsville train, and I'm going to say I've got all the time of the original train except for 15 minutes, but 15 minutes is 1/4 of an hour. So that's what I'm looking at there. Now I can fill in the distance by doing rate times time. And I'm going to actually use the distributive property now. I'm going to do 100 times x is 100x. And 100 times negative 1/4 is minus 25. All right. And so if we kind of look at this from a diagram, here's the town of Bridgeton, here's the town of Cogsville, and that total distance is 450 miles. Now my first train is going to be going, say, this far, stop, where it meets the other train. At a certain point they're going to run into each other, or not actually run into each other, hopefully, but pass each other. And at that point they will have collectively covered the entire 450 miles. The first train will have covered the 90x miles. The second train will cover the 100x minus 25 miles. And so that right there actually gives me my equation. I'm able to take the 90x, add it to the 100x minus 25, and that's going to give me my entire distance of 450 miles. Together they've covered all 450 miles between the two cities. So there we have our setup and we have our equation. Once again, either pause the video or and try to solve it, or just see what the answer is. All right, here we go. All right, so we can see from this that x is 2.5. So if we go back into our table here, that means that the Bridgeton to Cogsville train has been traveling for 2.5 hours. Since it left at noon, that means that the answer that we're really looking for is 2:30 p.m. We can do a quick check of that. It seems like that's not too bad. That seems relatively reasonable. But in order to check it, just realize that the first train would have gone 90 times 2.5, which ends up being 225 miles for a total distance. And the other one is only going for 2¼ hours, because we're taking away the 15-minute head start the other train got. Multiplying that by 100, we actually also get 225 miles. So this is just a coincidence that these two end up being the same. Oftentimes that's not the case. The key here is that they do add up distance-wise to 450 miles. That's the big key. And there you go. Hope this was clear, and let's move on. All right, this next problem comes, it's an adapted problem. It's a little different than the way it's written in the book, but it comes from page 53, number 17. Jan invested a total of $2,400 in two accounts, one paying 5.5% simple interest and the other paying 8.5%. How much did she invest in each account if her total earned interest was $253? So what we're going to do here is we're going to think about this as having two different accounts. I'm going to maybe make a little picture here. I'm going to put our money in each of these two things. And this first one pays 5.5%. Second one, 8.5%. And I'm going to put some money into the first one. I don't know how much, so I call it X. Now, in total, I have $2,400 to put in. So if I put X dollars in the first, I must be putting $2,400 minus X in the second. All right. And when I do that, I'm going to get a total of $253 in interest. So basically, at the end of the year, I'd have a total of $2,653 by taking my investment and adding it to my interest. Now I can actually set up my equation pretty quickly from there by taking the 5.5% of that X. I'm putting X dollars, I'm getting 5.5% interest. I express that by doing 0.055, which is 5.5%, times X. plus 8.5% of the remaining is 0.085 times the 2,400 minus x. And that's going to add up to my total interest, which is $253. So that's the interest from each account leading to what I have. All right, you know the deal. I'm going to solve the equation. You can pause it and try it, or just watch. Here we go. All right, so when we solve this equation, we get kind of a weird answer. X is negative 1,633.3 repeating. Well, the fact that it's 0.3 repeating isn't necessarily too problematic, because it's possible that it's just a rounding situation with the interest earned. The fact that it's negative really speaks out against this being a possibility. In fact, if we double-checked, we'd find that this is a trick question that, once again, has no solution. As a matter of fact, if we actually invested all $2,400 in the better account, we'd only earn $204 in interest. So we actually need to have more of an investment in order to make this work. So this is a trick question that we have to examine our answer to make sure that it doesn't make any sense, and that's how we know that there's no solution. But this is the correct process, so don't be upset if there's no solution. That is a possibility. All right, our next problem here comes from page 48, number 27. A grocer mixed cashews and almonds to produce 20 kilograms of mixed nuts worth $7.80 per kilogram. Cashews are worth $7 per kilogram, and almonds are worth $9 per kilogram. How much of each type of nut were used? So this is actually another problem where a table is useful, so I'm going to set one of those up. All right, and so this is actually similar to the distance equals rate times time. Basically, the relationship that I want to highlight here is that if I have a certain quantity of item and I multiply it by the unit price, I get the total value of the item. So here I have a row for cashews, a row for almonds, and a row for mixed nuts. So I'm going to just fill in what I know. I know that I have 20 kilograms of the mix. I know that the price of cashews, the unit price is $7 a kilogram, almonds is $9, and I want $7.80 as the unit price for the mix. Now, using the relationship up on top, which is a multiplication, I do 20 times 7.8, and I get a total value of $156. Now, as far as the quantity goes, I don't know how much cashews or how much almonds I'm putting in, so I'm going to start with one of them. Just say I'm going to put in X kilograms of cashews. The almonds, well, together with the cashews, it has to be 20, which means, kind of like with the investment problems, it's going to be 20 minus X is my amount. Now I multiply across. The X kilograms of cashews at $7 a kilogram. Total value of the cashews is 7X. Similarly, for the almonds, I get 9 multiplying by the 20 minus X. I'm going to use the distributive property now. I'm going to get 180 minus 9X. And now, I'm basically taking the cashews total value, the almonds total value, and I'm going to add those together to get the total value of the entire mix. So I'm going to take 7X from the cashews, add it to 180 minus 9X for the almonds, and set that equal to the value of the mix, which is 156. All right, here we go again. Pause it and solve it, or just watch the work. So this information tells us that we're going to be using 12 kilograms of cashews, which is X, and the remaining 8 kilograms is going to be almonds. And so if we just do that out, to check it, we'd see that that's $84 of total value for the cashews, and multiplying the 9 times the 8 kilograms, and then that would give us $72 of total value for the almonds, and that would be a sum total of $156. So there we go. All right, on to our last one. All right, last problem today. A jar contains 40 coins consisting of dimes and quarters and having a total value of $4.90. How many of each kind of coin are there? This is actually very similar to the mixture problems, we just have to consider that we have dimes, we have quarters, and we know, for example, that we have 40 coins in total. So if we have X dimes, we must have 40 minus X quarters. We know the value of a dime is 10 cents, which you can call 0.10, and the value of a quarter is 25 cents, so 0.25. And again, it's quantity times value, and so if there's X dimes, that's going to be 0.10 X dollars by kind of doing this multiplication. Doing the same multiplication down here, we're going to distribute the 0.25, and that's going to give me 10 minus 0.25x, and that's the value of the quarters. From there, I know that those two things need to add up to the $4.90 total. So I take the 0.10x, add it to 10 minus 0.25x, and set that equal to $4.90. And here we go. Let's solve that problem. And so this work shows us that we would end up having a total of 34 dimes. And since there's 40 coins in total, that would mean 6 quarters. And just double check that. The 34 dimes would account for $3.40, and 6 quarters, oh, yeah, get my R in there. 6 quarters would be $1.50. $1.50 plus $3.40 would be $4.90. So that's the answer that we're looking for, and there we go. That's how you solve a coin problem.